preparing to make M19/1 nut for this shaft, for the bearing thing. And now what I have done so far, this is 17.77 millimeter in diameter. This is the minor diameter of that thread. And then I have also there is a groove where I can put this one to the required depth, so it's already there. And it's a little bit wider, so when I connect half nuts, there is always some play in this, so it should now go like easily. So the next step, I will actually create this thread inside out, so I don't stumble into obstacles down there. I have a carriage stop here, so it will be quite at the end of this, so it's easy to put on a place there. So now what I will do, I will chamfer this end now. So let's see how this goes. Shouldn't be too hard to do. Just this chamfer doesn't need to be a very large one. There you are. So now we have it there. And now back to 0. Which one was our 0? This. Okay, there is a backslash. So, okay, now we go and have some cutting fluid there. That's very important in this case. And this time I try to run it into the correct direction. Running this in the wrong direction will ruin your work and whatever. So, okay. Well, let's see if I really am going out. It's always a good idea to check outside the thread. Yes, it is coming out. Good. Go in there. Then we make the first cut, which is 2/10 of a millimeter. And now, correct direction. And then engage the nuts. It's pretty silent, but it's definitely making the thread. Wow. Okay, then I go back around 0, go back in to the end. Dial the next. Let's go directly to 0.5 millimeters cutting depth. And now let's hope this yeah. And it's still really silent. Wow. This is going to be a really nice thread. Dial in that much. Oh, hopefully it doesn't break on me. This is really exciting. Yeah. Yeah, definitely a spring pass. You could see it didn't cut a lot. So there you are. purify the outside. And now I make a chamfer here, and this one is, I have learned something about this lathe. You can actually feed in with the power feed, and then at the same time use this to control the eggs. And you get quite good chamfer. Let me show you. Because this is a nut. Well, it's not perfect, but it's okay. That's it. I can always turn it off right away if it gives me trouble. Not yet. I believe the feed is too slow. Looks like being too slow. It's correct. Wow. And it smokes like hell. Ooh. Oh. Luckily it's summer and we can have our window open. It goes nicely. But it doesn't curl the chips like it should. Well, that was sort of an exercise, and I would say successful exercise, and I believe this is hot. Well, it left the burr in both sides. So, okay. I think this was because of the thread. So it left here the threaded part. Yeah. Okay, I put it there using one parallel and just hammering it with plastic hammer a little bit. Now we beautify this surface. Well, I already tested the thread and it's too tight, so we need to take some away from this thread, and this will be interesting as we need to chase the thread. It's a simple task once you know what you do. I have done it several times because it's not so uncommon that you end up with a part that's not suitable. Well, especially when you are dealing threads like this. So let's first beautify it. It has a horrific burr there, and just take this burr away and face the surface. That surface finish doesn't leave a lot to desire for, and it's also very, very, very smooth. So the first thing when you do this, there is always some backslash on the gears, etc. So when you rotate this, it doesn't start to move right away. So you need to get rid of that. And well, so you go inside there, like that, and you don't need to do anything, the place is irrelevant at the moment. So now you engage, and you should really shut down the machine, because if this starts accidentally running on you, I switched it off, it will not run on me. So if it starts running here, there is a great chance of accident as well here. So the thing is that you need to set the half nut on. Now it's on. And then you rotate until it starts to move. And that was again the wrong direction. You have to move it to the same direction you are going to. Okay, I think we are moving. Yeah. So now all the backslash is away from there. And then you very gently, first by sight, look where the groove is. Yeah, you can, it should be really clean. The first groove is the most visible. So you just locate it inside the groove and then wiggle around very carefully and then feel, well, there you should be. It's now in the bottom of the groove. So then you leave the compound alone, and then you know from here that it was 10.25 was the so you can now come back with the carriage to 0, and it should, when you disconnect the nuts, it should come out freely, and it does. Okay, so now it's if you did everything correctly, so now it is in a correct position to chase your threads. So we feed this in. This time we don't need to stop because we can go in like that. And I dial in here the 10.25. Oh, this will be fun again. Okay, switch the machine now on. So it's now 10.25. 1.25 millimeters cutting depth. And now let's see what happens. I will not make the thread with that speed. That would be disaster. Well, this is more like that. So let's connect the nut and destroy the part, right? Wrong. This should work all right. Let's see. It should actually take almost nothing, and it didn't. It just cleaned the thread. So our setup was successful. So I can now test this and see whether it works. Already, I mean, because the first cut might have done it. Well, it's tight. I don't want to put it by force, so okay, it's still binding. Well, now it's all the way, and it's not too loose. Very good. Okay, this is now testing the accuracy of this Morse 2 taper in terms of concentricity. And I have found out that it's not concentric. It's something like there is a total deviation of 0.06 of a millimeter. That's quite a lot, actually. Let's see if that inherits to Morse code, if I put one into there. Okay, now I have put in the Morse 2 cone into there. Well, this has proven to be quite straight, this one. So let's see. So it's actually now 0.07 of a millimeter deviation. Okay, now I have finished one nut, and yeah, and I also measured the runout of this one, so it's about, in the maximum it's about 700ths of a millimeter, I would say. Well, usually less, and for this application, this well, it limits the use a little bit. Drilling, for example, with very small drills, that runout will ruin your drill immediately when you put it in contact with metal. But yeah, doing that kind of drilling, I'm still wondering how I will do that, if I need to do that kind of little drilling, like 0.3 millimeter holes. Okay, anyway, well, I have vaccinated with this one. The bearings, this is containing molybdenum sulfide grease, and I have put filled these bearings with this grease, and well, it's a very nice tool to have. This kind, you can put your grease exactly where you want to. So you don't become very greasy when doing that. Yeah, all in all, it works now. It's very steady, I would say, so rigid, and that's important when I do put a tool in here. For example, a radius tool. So if this would be already flimsy, it would chatter for sure. Okay, in the next episode of Finno machining, we shall make something to rotate it with, a handle that will be. I have already bought some material for that one, 70 millimeter in diameter steel bar. I will attach a photo on that one. It's really, well, it's a challenge to cut a suitable piece from that for this, but after that, this is wonderful material. It's the same material which I made some of these parts, for example the nut, and this behaves really nicely. So it's a good material, yeah. And then we will make a beautiful nut for that end, and there we will do something special. This is M15/1. I don't have the tab for that size, so it will be single point threading, and this starts to be quite small hole to be threaded with a single point threading tool. But I have one idea for that one, and it is dealing with broken tabs. Okay, but that will be in the next episode of Finno machining. Till then, see you!